the API functions, which I will teach you how to build your custom API functions SWM5. So this is our standard run swim project, which we have looked in previous video, similar to the one which we looked in like couple of other videos. We are using this particular function run swim, and our application will get three inputs, which is input file path, report file path, and binary file path, and then we will use those three to run our simulation. We will use this swim run function to run a simulation. And yes, so in last video we looked at all the standard API functions available in SWMM5, and those are actually not stored, but uh, they are defined in swim 5.h and swim 5.c file. So this is the h file where we declare the functions, and you could see these are all the standard functions which you could get with the official swim5 source code. Not source code, but the official swim5 API. And let me see if I have the documentation. Yes, so this is the documentation, and over here we have all the swim5 functions. Okay, and if we look at these functions, these are basically the same functions: decode bit, write line. Set value, set value would be somewhere over here. Yeah, set value. So all these functions which we get with SWMM5 API are all defined in this particular file. And what we will do is we will create our custom function and store in these two files so that they are available with our standard PLL, which gets compiled by this particular project Swimfire. Okay, and for that, what we will do is yes, see, we'll create a function, and what a function will do is when you give a ID of a junction. So I have junctions over here. So if I give ID of any of this particular junction, the function should return the junction object or the node object, and it is pretty useful. So uh, if you can't find objects within your SWMM5 project, it becomes really hard to manipulate the data with inside the objects. So uh, in any hydraulic modeling application, finding object API is the mostly used API, and that is what we will be developing today. We'll be developing a API which will return a memory address to a junction object. So I will write over here. Our function will return a node pointer. So node pointer will be defined in object dot h. I'm in the wrong folder. It's over here, objects.c, and if I do t node. So this is the struct. Okay, sorry, I'm in the wrong struct. Okay, so this is the struct t node. It starts from line 490, ends at 529. Over here, it defines a struct. which stores the value of a particular node object, and we will the function which we are creating, it will return a pointer which is memory address to this particular object. Okay, and we are writing it over here. So I want to return an object called as dnode pointer of type dnode pointer. I'll name it as, yeah. So I will name the function as w uh, SWMM underscore get node object, or get node pointer. It's not actually returning the object, but it is returning the pointer, or the address, I would say. And the input for the function would be the node ID. So that would be char pointer, right? As write the name of the input variable as node ID, and this will consist of our project, sorry, function. And for our function, we will use a existing API, not API, but a function called as project underscore find object. Okay, project underscore find object. Okay, this one. And we will write the type of the object which we need to find, and then node ID. So what this particular function will do is, this particular function has been defined in project.c file. Just copy it, and let me see if I can find the right file. Yes, yes. So this is the function. What it does is it uses hash table to find the index of an object with a given ID. So the given ID with the node ID, and it will find its index in the global variables for the node. For example, we are trying to find a node object. So where it is global. In globals, we have this particular global array called as node, and when we use this particular function, it will return the index of the node with the given node ID in this particular array. And then we will use the index to retrieve the object and its memory address. Okay, so yeah, over here, so now this function will return the index of the node. So I'll write it will be int, so int node index. Okay, it has returned a node index. uh, and now what I will do is uh, I will use node and node index. Sorry, node index, and yep, and its memory address. That will write and percent, say return. So yes, this is our function, and this should most probably work. And we can add a if statement if node index node index is less than 0. Just return uh, exit maybe. We'll return nothing. Let's see if it works. Yeah. This is our function, and we will copy it declaration and paste it in the header file. Okay, over here. And now we will compile it. Okay. And what we can do is before we use it, I will open my developer command prompt, and I will yeah, before I discuss the developer command prompt, we need to discuss what is this DL export. So you can see this in the header file as well as in the C file. So wherever the actual definition is for all these functions, these are internal functions. The external functions will be at the top. Yeah. So these are the API functions, and you can observe that for all the API functions, there is this particular keyword DLL export. This particular function actually marks this, sorry, this particular statement marks this function as a export function so that it could be consumed by other binary files like DLL files or executable files. What it actually does is there are many functions in this file, and if I open developer command prompt, I can show you what it actually does. So I will go to the current directory, the CD of my current build, and just right click, open file in Explorer and debug. Over here I have the DLL file, so I'll just copy the path and paste it in the developer command prompt. Now what I will do is I will write a command called as dump bin, then forward slash exports, then the name of the DLL, that is SWMM5 dot DLL, which is the name of this particular file. And if I hit enter, it will give me the list of all the DLL functions which are available consumed from this particular DLL. Okay. You would see there are almost 20 functions which could be consumed, and the function which we wrote is not available over here. Okay. But we are going to make it available and we can use it with other applications. So how do we do that? Let's add a export declaration so that when compiler compiles the source code, it knows it has to be exported and it has to be consumed by other uh, files. For that, what you need to do is you need to add something called as declaration underscore underscore uh, Deckel spec and in bracket DLL export, and this should work. And then over here you need to add the calling function as well. Underscore underscore C. Okay. Yes. So Now we need to copy this and paste it in the header file as well, and add a semicolon at the end. And if I compile this, okay. Oh, yes. So one thing to note that you need to add the objects.h file as well over here. Uh, mm, this one. If it doesn't, if you don't have this file, if I remove it, you will get certain errors. But yeah, make sure that this file is there. Back to the point. Now we have added the declaration in swim5.h and .c file, and let's compile it. Now, if I go back to my developer command prompt and write the same command, dump bin export swim5.dll, uh, you could see we don't have any method called as swim underscore get node, or what was the name? Yeah, get node pointer. We don't have any such method, get node pointer. And if I run the command again, now I will get, uh, yes, I will get this particular function called as get node pointer. And you would see now there are total 21 functions. Earlier, there were only 20 functions, which means we have added one function which could now be consumed by any other binary file, which could be a DLL, or it could be a uh, executable file. One thing to note that what I'm doing over here is I'm using a utility in my operating system to find all the functions, the exported functions from the DLL. So I'm not using a C compiler or C++ compiler. Instead, I'm using a Windows operating system tool to uh, find out all the exported uh, functions. And yes, that's it. So which means any function can use it on the operating system if they know which uh, call should be used. And for that, the other functions could use this particular file as a reference, wherein they could find out all the uh, supported functions. Okay, and its calling functions, input parameters, and other required information. So now that we have created our function, let's test it out. What I will do is I will open the main.c file, and over here I will paste it. Okay, so I need to find a node called as J11. Let's go with J10 and write J10. And this particular function will return a node uh, pointer. Let t node pointer and node, just write node 11 or 10 equals to, and you could see it is throwing an error because our main.c file doesn't understand what t node is, because that has been defined in a file called as objects.h, this file. So we will include it at the beginning of a code, hash include uh, objects.h. Okay, and if I come down over here, Yes. So now the error is gone. Uh, and another thing which you need to remember is before we uh, try to find a node, we need to open the swim project. So I'll just write SWMM underscore open. This particular API function is available with the standard swim uh, API library. I'm not sure why it is not working. Let me see. Okay, yes, now it has found out the function. So now what I will do is I will add a breakpoint and I will compile the, okay, it got a error and that is in swim5.h, and the reason is it cannot understand what this t node is for, and the reason is we haven't included uh, objects.h, object.h. Yes, so now if I go down, you could see the error has disappeared. Go to main dot, I'll go to main.c and I will compile it again. Now I won't see any error. What I'll do is, yeah, so we have hit the breakpoint, and now I need to see what is the value of my variable node 10. Okay, the value is, it is blank, null value, because we haven't initialized the variable yet. I will step over, and now you could see the variable has been initialized. You could see all the values, and I will open the swim inp file, and for J10, let's see what is the invert elevation. Invert elevation is 4957, 4957.8, 4957.8. Yeah, that's right. So this is how you can create your API functions and then build custom C applications to consume it. And you can even build uh, programming, build applications using programming languages other than C and still consume these APIs. And in the next video, we will be looking at how to use them in other programming languages. And yeah, uh, thank you for watching this video. Bye.